Okay, so that was pretty successful. We can now generate our output code into a file of a name of our choosing, as we saw here with hello. What I'd like to do is just understand a bit more about the code that we're using now. So I mean, obviously I can make changes and say hello Mars or hello Jupiter or something like that in here. That's fairly straightforward to modify that text. But maybe I'm just a little bit confused as to what's going on here. Can you shed any light on that for me?
Yeah, let's have a quick, very brief overview of the contents of this source file, just to give us a little bit more of an understanding of what's going on. So every C program, every piece of code that's written in C has to, at some point, it may contain many files, but has to at some point have a main function.
And that's the starting point. So the compiler, the entry point. So the compiler needs that to be able to enter any piece of code from a command line C.
Exactly. So when you run a program, the compiler knows that it will always start
That's the starting
at
point.
the first line of code within the main function.
And what does that int in front of the word main mean?
Well, one of the standards about C is that any program that you run, it will have to return a code, normally called an error code, and what that int does is that says that this function will return a number value, an integer number value.
Yeah, is that what that return 0 is down the bottom?
That is exactly what that return 0 is. So in this case, we're not using it for anything interesting.
Yeah,
but
but when that code is finished, the code will return 0. In other words, telling us that it's running.
Yeah. So in the future, if we were to utilize this program as part of a batch file or something like that, we could then check the error code or the return code of our program. We've also had this interesting include statement up here. Now, when we look at this printf, what we're doing is we're saying we'd like to print a formatted string, printf, print formatted string, and that's to say hello world. Now, what is this printf? It's not a keyword. Printf is another function, and we're calling this function because we want to use what this function offers.
I'm starting to see where you're going now. So you're going to tell me that printf comes out of the STIO or standard IO?
Where does this function come from? We have not created it. It must be issued by somebody somewhere for the C compiler to be able to link it into our program. Now, printf is what's known as it's a very common function that's part of the standard C libraries. And the standard C libraries come with most GCC and other C installations, and it allows you to write software that can be compiled on different compilers. Yeah.
So hang on. So a library is something somebody else has written the code for us because we're too lazy to write the code ourselves.
Yeah.
And we can just call it in and use the code that they've done without having to get our hands dirty with hundreds of lines of code.
Exactly. Already tested, already debugged, common, well optimized, we may as well use it. Why do we want to reinvent the wheel? Okay, so what we do to use this printf function, which is again a very common standard C function, we need to find the file that declares this function. And in this case, it's declared in a standard IO file.
So how would we know that?
We would have to search for that. We'd have to search for the contents of the standard C library, where you'll find thousands of functions and lots of different files. So some functions may not be in the standard IO, they might be in the standard in or some other library files. We need to find that.
But while we're learning, we just need to trust the fact that we've been told that it's in the standard IO.
Let's take this line out just for fun, save this, and now let's try and compile our program again, exactly the same way.
So you're using the up arrow key to revisit.
Yeah, up arrow key brings back the last command I typed.
Previous commands, so that saves a lot of typing, that's useful.
Okay, let's run this code. Now we have an error, and what it's saying is there's an implicit declaration of function printf. It means I've used this function printf, but I have not declared it anywhere in my program. It cannot find it, so therefore it cannot compile.
And it's even told you just above your cursor, look in green,
Yep.
to add #include standard IO. That's really nice.
That is won't happen if you've written the function, the name of the function incorrectly, or it's one of your own functions. It only knows this because printf is such a standard function. So that's just a hint at. But what the important thing here is saying that on line 7, the first column, there is a statement that it cannot compile. So when we come down to line 7, I think we have the line numbers down the bottom, do we? Or you can
No, we don't on this editor.
view status bar. Okay, here we go. Line 1, column 1. So now we move down, we find line 7, column 1 is our printf function. So this is where the compiler's telling us I have a problem here. Yeah? And that is because it cannot find this printf function that I would like to use.
Okay, so finally convinced me, put it back and make it go again.
So I put it back.
Save it.
I save it, so I'm saying now that I want to include all the functions available in the standard io.h file that's provided
Which is
as
lots
a
and
library.
lots of things.
Lots and lots
in
of
addition to printf, yeah.
And now I rerun it again, no problem.
No problem.
So that's what the include statement is doing here. We are including another file called standard.io, stdio.h, that contains lots of functions. And in that file, it contains a declaration for printf function, and printf prints whatever I include in its argument onto the console. So when I run this program again, if I run hello, you can see I see hello world. Now if I just write, if I change this
just
word,
make a change there just to convince
John,
our listeners that we aren't just doing this and cheating or anything.
I've made the change. What do I have to do?
You've got to recompile
I've got to
again,
recompile.
otherwise it will be the same as it was before.
So recompile,
Yeah.
and now I run the program, and now it
there
says
it is,
hello
yeah,
John.
there's the change. Okay, so there's just one more thing I want to know as a beginner here. What are these brackets here? So why has that got a curly brace here?
The curly braces. The curly braces are the start and stop identifiers of various different things in C. What they do is they group blocks of code. So for this case here, I have declared my main function. My main function starts here, contains all of this code, and ends here.
I understand.
Now it's very important that you get these right. If I put another curly brace in here without a matching without a matching end brace,
that's going to give me an error.
I'm going to get a compiler error.
Yep, there it is.
So it's very important that these
So I've
braces
done a bit of
match up.
Python in the past, and in Python, to group code together, I would press the tab button and I would push it across. This is similar to using the tab in
Exactly
Python,
the same.
right?
It's exactly the same, and normally you'll find that most C coders also put tabs in.
And that makes no difference to the code.
Makes no
They run
difference to that.
exactly the same.
But it makes it a lot easier to read. It makes it a lot easier to read and find where blocks stop.
So
and start.
when it comes down to reading, I'm going to do something absolutely mad now. What would happen if I did this?
That wouldn't work because there's multiple statements on the line, and you have a curly brace without a starting brace. Oh, here you do have a. No,
I've got
that
the
would
starting
work.
brace.
That would be absolutely fine. Let's try.
Let's try.
Let's save it. Let's compile it. No problem at all. Let's run it. I go through my history and I can't find my hello, so I type it in. See, it runs no problem. The new lines, white spaces, I could put white spaces in here, it will make absolutely no difference at all because it's looking at this curly brace.
It's just
and this
obeying
curly
those
brace.
rules.
And the other difference between Python and this is, of course, you need to terminate every command individually.
Okay, yeah. But the reason we write things like that, so putting it back like it was, the reason we write things like this is just because it's neater to look at, right?
Yeah, much easier on the eye.
Much easier on the eye. So I don't like that as much as I like this. That's my preferred.
Yeah.
And that's really easy to view and see what's going on. Excellent. Fantastic.